Hello everyone, welcome to my calculus lecture. In this lecture, we study the derivatives of trigonometric functions. We start with derivatives of y equals sine of x and y equals cosine of x. The derivative of sine of x is given by cosine of x, and also the derivative of cosine of x is given by negative sine of x. Well, how do we know? So let's calculate that, okay? So we're going to calculate the derivative of sine of x, and similarly, you can also find the derivative of cosine of x in the same manner. So let me go to my notepad. So we want to calculate this, right? D by dx by sine of x. So, right, so we are supposed to have a cosine of x, okay? All right, so let's start with d by dx sine of x. So by definition, uh, I'm going to put this guy inside this box. Uh, so d by dx sine of x equals cosine of x. Okay, so that's what we want to show. Okay, so by definition, derivative of sine of x is given by a limit h goes to 0, sine of x plus h minus sine of x all over h, right? Okay, so in this case, there is one thing you will have to remember, okay? Sine sum formula, okay? Maybe I'm going to use different color. So the sine sum formula that you learned in trigonometry, that's what we are going to use here, okay? So sine of uh, x plus y equals sine x cosine y plus cosine x sine y. Okay, so that's a sine sum formula. So using that, sine of x plus h can be written as sine x cosine h plus cosine x sine h minus I have sine x over h. Okay, so now limit h goes to 0. So these two guys have sine x in common, so we can actually factor sine x out. So I have a sine of x is factored out, and what's remained is cosine h minus 1 over h plus, now we have a cosine of x times sine h over h. Okay, so here also, the two things you will have to remember. We did talk about the following limits. So limit h goes to 0, sine h over h. This is very important limit, right? Which is 1. Also, using this limit, we also calculated that was, the one of the examples I talked about. Limit h equals to 0, cosine h minus 1 all over h, that is 0. Okay, so we talked about these two limits in my earlier, the lecture, right? When I was talked about like this limit, okay, so this was also calculated as an example. Okay, right. So I'm not gonna repeat doing this, okay, especially this guy here. Right. So anyway, so that's the sine x times limit of this is 0, so the first part goes away. And I have cosine x times limit of this is 1. So altogether, what I have is just cosine of x. So I just showed that the derivative of sine of x equals cosine of x. Okay? In a similar manner, actually, the same manner, we can also calculate, the derivative of cosine of x equals negative sine of x. Okay? Actually, why don't we do this? Right. So d by dx cosine of x by definition, limit h goes to 0, cosine of x plus h minus cosine of x all over h. Now this time you will need to know the cosine sum formula, right? That again you learned from trigonometry class. So cosine sum formula, that is cosine of x plus y equals cosine of x cosine of y minus sine x sine of y. So that's cosine sum formula. Using this cosine sum formula, this equals limit h goes to 0, cosine x cosine h minus sine x sine h minus cosine x all over h. So first term and the third term, right? Last term have a cosine in common. So, I'm going to factor out cosine of x, and what's remained is cosine h minus 1 over h. Okay? Minus sine x times sine h over h. So again, this guy here, cosine h minus 1 all over h when h goes to 0 is 0. And also here, sine h over h when h goes to 0 is 1. So overall, we have negative sine x. Therefore, now we found d by dx cosine of x equals negative sine x. Okay, so once we have, and we do have derivatives of sine of x and cosine of x, right? Then the rest can be found by using like either the baby quotient rule or quotient rule. Okay. So next thing I want to talk about is the derivatives of y equals secant x and y equals cosecant x. Okay, so using the reciprocal rule, aka, okay, baby quotient rule, along with the derivatives of sine of x and cosine of x, there we obtain the derivative of secant x equals secant x tangent x, and also derivative of cosecant x equals negative cosecant x times cotangent x. Okay, so let's check that out. So going back to my notepad. Okay, so we first calculate the derivative of secant x. Secant of x, as you know, that's the reciprocal of cosine, right? So d by dx, that's same as 1 over cosine of x. So we use the baby quotient rule. that's going to be negative negative sine of x, right? So that's it. Negative cosine x prime over cosine x squared. That's the baby quotient rule. So negative cosine x prime is a negative sine x. So with this negative sign, that becomes sine of x. Okay, so we have sine of x over cosine squared x. And so, this can be written as 1 over cosine of x times sine of x over cosine of x. 1 over cosine is secant of x. Sine x over cosine x is tangent, right? Tangent of x. Okay, next we calculate the derivative of cosecant of x. Cosecant is by definition the reciprocal of sine of x, right? 1 over sine of x. So again, we use the baby quotient rule. So that's going to be negative sine of x prime over sine of x squared. Sine of x prime is cosine of x, so I have negative cosine of x over sine squared x. And this can be written as negative 1 over sine of x times cosine of x over sine of x. And 1 over sine is cosecant x, so negative cosecant of x times cosine over sine is cotangent. So we are done, right? Okay, so I believe these are the last set of the trigonometric functions. We want to talk about their derivatives, right? So derivatives of y equals tangent of x and also y equals cotangent of x. That's what we want to talk about. So using the quotient rule, along with the derivatives of y equals sine of x and y equals cosine of x, we can obtain the following formulas. So derivative of tangent is secant squared, and derivative of cotangent is negative cosecant squared. So let's check those out. So we are heading back to my notepad. Derivative of tangent of x equals secant squared x, and derivative of cotangent of x equals negative cosecant squared x. Okay, so let us calculate the first one. So d by dx tangent of x. Tangent is by definition, that's cosine, sine over cosine. So sine of x over cosine of x. So using the quotient rule, that's going to be sine of x prime multiplied by cosine of x minus sine x times cosine x. Oh, cosine of x prime all over h. So that equals sine of x squared. I mean, sorry, sine of x prime is cosine of x. So I have cosine squared x. Okay, cosine of x times cosine of x. So cosine squared x minus sine of x times cosine of x prime is negative sine of x. So with this negative 1, it becomes positive sine squared x, right? All over, oh no, sorry, not h, it's cosine of x squared, right? So here also, I have a cosine squared x. And cosine squared x plus sine squared x, this is well-known identity, trig identity, right? We know that that equals 1. So we have 1 over cosine squared x. So 1 over cosine is secant, so that's secant squared x. Done. Okay, so next one, we are going to calculate d by dx, derivative of cotangent x in a similar manner. So cotangent is cosine over sine, cosine over sine. So by quotient rule, again, that's cosine of x prime sine of x minus cosine of x times sine of x prime all over sine x squared. So this equals cosine of x prime is negative sine x, right? So negative sine x, negative sine x, so negative sine squared x. Negative cosine times sine x prime is cosine, so that's negative cosine squared x all over sine squared x. Okay, now these two guys have a negative 1 in common. So if you factor out negative 1, what's remained is sine squared plus cosine squared, which equals 1. So I have a yeah, negative 1 over sine squared x. 1 over sine is cosecant, right? So that's negative cosecant squared x. Okay, good. Actually, there's another way we can also calculate the derivative of cotangent x. This is another way you can do. So d by dx cotangent x, right? Cotangent x. Note that cotangent is the reciprocal of tangent. So 1 over tangent of x. And so using the baby quotient rule, in this case, baby quotient rule, the same as minus tangent x prime over tangent squared. So, the tangent x squared prime is a negative, right? Tangent x prime is secant squared x over tangent squared x. Okay? Right. Now, secant is 1 over cosine. So that's 1 over cosine squared x. And also tangent is sine over cosine. So that's sine squared x over cosine squared x. Okay, so the numerator, in this case, what I mean by numerator is this guy here. And the denominator have the same, each fraction have the same denominator, cosine squared of x, right? So you can multiply the numerator by cosine squared x, denominator also by the same number, cosine squared x, right? And we still retain the equality. So what happens is basically like, what, we cancel. What it means is we cancel these two and we end up getting negative 1 over sine squared x. So 1 over sine is cosecant. So this is negative cosecant squared x. So we get the same thing, of course. Okay, so that's it. And more details of my discussion in this lecture can be found in my lecture note at the following address, right? As usual, you just need to click on this link, right? This address, which is hyperlinked, that will take you to the lecture note. And also, if you want to visit my main blogger site, right, where you can find the other lecture notes, you just have to click on this word blogger, which is also hyperlinked. Okay, thank you very much, folks, for watching and listening my lecture. I'll see you next time. Bye-bye.